Okay, welcome back to geometry, everybody. We've been spending quite a bit of time last week talking about parallel lines. And so we'll talk briefly about perpendicular lines today. And then after that, we'll go into slopes of lines in detail, which is probably something that you've already seen before this year. So it won't be much of a surprise to you. But quickly, let's look at perpendicular lines first. Perpendicular lines, in particular, let's talk about a perpendicular bisector of a segment. And I've got the definition up here. So the perpendicular bisector of a segment is a line which is perpendicular to a segment at its midpoint. So in the diagram, you can see line segment AB, and the red line is the perpendicular bisector of that segment. So it does two things. It's not only perpendicular to the segment, which you can tell by the red boxes, it's also the bisector of that segment. It goes through point M, so that means that segment AM and segment MB are congruent. So again, the red line is the perpendicular bisector of segment AB. Okay. Let's talk about the shortest distance from a point to a line. The shortest distance, or the shortest segment from a point to a line is perpendicular to that line. So if you look at this point P I have here and then line AC, if you're an ant sitting on point P, you have several routes to go to line AC. You can go down segment PA, you can go down segment PB, or you can go down segment PC. So which one's the shortest? Well, we can't go by looks. We have to kind of have a definition for that. And it tells us right here that the shortest segment from a point to a line is the perpendicular to that line. So using that definition, we can say that the distance from a point to a line is the length of the perpendicular segment from that point to the line. So the shortest distance would be here segment PB, or 5 units, whatever those units are. So I guess we already answered example number 1. It says, what is the distance from point P to line AC? Well, it's the length of the perpendicular segment from point P to line AC, which is 5. So, example number 2, write and solve an inequality for x. So if you look back up at the drawing, we see a side of that triangle there from P to A is x plus 3. We know that that's going to be greater than PB because we know that PB is the shortest. So when we go to write an inequality for that, we can say, well, x plus 3 is greater than 5. X plus 3 is greater than 5. And then solve that. So x is greater than 2. Okay, so to summarize that again, it's very actually kind of a simple idea of that. What is the shortest distance from a point to a line? Well, it's the length of the perpendicular segment from the point to the line. Okay, now here's where we have something that's really important to us this year, and it's something that you also probably had last year, and that's the slope of a line. So you see here in my diagram, line AB, point A is at 1, 1, and point B is at 5, 7. So when you're talking about the slope of a line, you have to think about the rise and the run. So the rise is how far, if you're walking from point A to point B, how far do you go up over the course of your trip? Well, you can calculate that by taking the difference of the y coordinates of those 2 points A and B. So we see that point A is at 1, 1 and point B is at 5, 7. If we simply subtract the y coordinates from A to B, that'll be 7 minus 1, which is 6. So your rise as you go from A to B is 6. Your run is how far you go sideways, not how far you go up and down, but how far you go sideways as you go from A to B. Because really, if you're walking from A to B, you're doing two things at once, right? You're going sideways and you're going up. So your run is the difference of the x coordinates. So if you look at the 2 points, A and B, you simply subtract their x's, so 5 minus 1, which is 4. Now I put that little point down here. Let me point it out right here. Highlight that. That point right there I just circled in yellow is directly underneath point B, so straight down from point B. So it's going to have the same coordinate as point B. So we just stole that 5 and used it as our x coordinate. And that yellow point there also has the same y coordinate as point A. So we stole that y coordinate from point A. So that yellow point there has coordinates of 5, 1. So if we put that point on there, we can form what's called a slope triangle. And I drew that in blue there. And you could have counted the length of the legs of that slope triangle to be 6 and 4 if you have your line on graph paper, but you don't always have your line on graph paper. So that's the situation where you'd want to use that slope formula, rise over run. Okay. So there's your slope formula, and you should memorize that for sure. The slope formula, if you know 2 points on a line, and on this line right here, besides giving them coordinates, I also gave them variables here. So point A, which I should have put, let me move that over here a little bit. Point A is right here. That's also, I'm calling x sub 1, y sub 1. And then point B is x sub 2, y sub 2 if we use variables. So the slope formula, the rise is going to be y sub 2 minus y sub 1, and the run is going to be x sub 2 minus x sub 1. So if you put all that into the rise over run format, that gives you the slope formula. So there's your slope formula, which you need to memorize. M stands for slope. I don't know why, but it does. And so M slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, those being the coordinates of 2 points on the line. Okay, so I got 4 cases here. And in my first case, and by the way, I hate that little line, that black line appeared there. Let me see if I can make that go away. I may not be able to. Nope, that's not going to go away. It's just not. Okay, well, concentrate on the red line there. And we know 2 points on that red line are 2, 3 and 7, 5. So we don't need to actually graph this line in order to find its slope. We can just use the slope formula. So the slope is rise over run. So subtract the y coordinates again. That's 5 minus 3. You can see that in my calculation. And subtract the x's for the run. So that's 7 minus 2. So you got 2 over 5. So the slope of that line is 2/5. And notice that it's a positive slope and the line rises to the right. And we'll talk more about that here in a few minutes. So positive slope line rises to the right. Here is a situation where your line is vertical. And I have 2 points on that red line. So one point is 4, 5, and the other point is 4, -3. Now watch what happens when you try to use the slope formula now. We do the rise, which is subtracting the y coordinates, is 5 minus -3. That gave us 8, divided by the run, which is 4 minus 4, which gave us 0. So if you go from one point to the other, you rise 8, but you run 0. And so when you divide by 0, which you cannot do, you have no slope. You cannot divide by 0. So we say the slope of that line is undefined, or we just simply say it has no slope. You cannot divide by 0. Okay, look at case 3. This time my line is horizontal. And one point is 3, 4. The other point is 6, 4. Notice they have the same y coordinate when you have a horizontal line. So when we apply the slope formula, rise over run, we subtract the y's, that's 4 minus 4 on top, and subtract the x's, that's 6 minus 3 on bottom. So we have 0 divided by 3, which is 0. So whenever you have 0 on the top of the fraction and you divide, you get 0 for an answer. When you have 0 on the bottom of a fraction, you can't divide by 0, so you have no answer. So here we do have a slope, and it's called 0. So we have that line has a slope of 0. So it does have a slope. Okay, so our fourth situation we might have is if the line falls to the right. So I chose 2 points on this line, 0, 8, and 8, 0. I applied the slope formula, so if we subtract the y's, 8 minus 0 is 8 on top, and subtract the x is 0 minus 8 is negative 8 on bottom. So 8 divided by negative 8 would give us negative 1. So notice that we have a negative slope for this line, and it also falls to the right. And that always happens when you have a negative slope. Now, one thing I should mention is when you're calculating your slope formula, if you start with 1 point for the y, like I did here, 8 minus 0, you have to begin with that same point when you use the x-coordinates. So 8 minus 0 is on top, 0 minus 8 is on bottom. You can't start with 1 point for the y and the other point for the x. That'll give you the incorrect slope. And so just make sure you're consistent. You can start with whatever point you want. Just do that for both x and y. Okay, now to kind of put this together, in a summary here, I have 4 drawings side by side here. The first one shows a line which is increasing to the right, so it's going up as you go to the right. That line has a positive slope. If your line falls to the right, your line has a negative slope. If your line is horizontal, you have a slope, but it is 0. And if your line is vertical, it does not have a slope. No slope, or we say undefined. So that's a summary of the slopes. Okay, we actually have 2 theorems here today. Luckily for you, we're not going to prove them. We prove almost every theorem this year that we have, but here's 2 that we're not. The first is the parallel lines theorem. It says 2 lines are parallel if and only if they have the same slope. So that's your biconditional coming back. So remember, biconditionals have if and only if in them. So we can say this 2 ways. If 2 lines are parallel, then they have the same slope. And if 2 lines have the same slope, then they are parallel. So we're not going to prove it, but I think you can look at my little drawing there of the 2 blue lines, and I indicated that they were supposed to be parallel. They do have the same slope, don't they? I mean, they have the same tilt. They have the same rise and run as you go to the right, from left to right. So yeah, they would have the same slope, and if they're parallel. Now, the other theorem we have today, which is not going to be proved, is the perpendicular lines theorem. And this theorem is also biconditional, and it says 2 lines are perpendicular if and only if they have opposite reciprocal slopes. So let's say I have one line there which has a slope of 2/3. You can see that right there. And the line which is perpendicular to it, then according to this theorem, would have the opposite reciprocal slope of -3/2. So some people get confused about opposite reciprocal. So there's really 2 things involved: opposite and reciprocal. Reciprocal, we know what that means. You just flip over the fraction. So we flipped over 2/3 to get 3/2. But opposite means write the opposite sign. So if it's positive and your opposite is now negative, if your fraction is negative, now it's now positive. So 2/3 and -3/2 are opposite reciprocals. Just to give you one more example of opposite reciprocals, let's say that first line had a slope of 5/7. Then if that other one line was perpendicular to it, it would have the opposite reciprocal slope, which is -7/5. So again, it's a biconditional. We can say this theorem 2 ways, forward and backwards. If 2 lines are perpendicular, then they have opposite reciprocal slopes. Now backwards, if 2 lines have opposite reciprocal slopes, then they are perpendicular. Okay, so those are a couple theorems that we need to know in our work this year. Okay, I have one more example. So I'm going to throw this question out to you. You see 2 lines there. One is blue, one is red. My question is, are these 2 lines parallel, perpendicular, or neither? And you cannot go by what you think it looks like. Looks can be deceiving. You have to go by comparing their slopes. So that first line, the first blue line, I have chosen one point there at -1, -4. You see that there. Right there, there's 1 point. The other point here is at 3, 4. And if I go to calculate the slope of that line, which I did down here in the blue ink, I'm using the slope formula, subtract the y-coordinates. 4 minus -4 is the rise. 3 minus -1 is the run. So when I do the calculations, I have 8/4, which is 2. So the slope of that blue line is 2, positive 2. Now, My red line, which I also know 2 points, negative 2 comma 2 is 1 point on that red line. Positive 5, negative 1 is another point on that red line. I'll calculate the slope of that red line using the slope formula. So again, subtract the y, so 2 minus negative 1. That gives 3 on top. That's the rise. And then subtract the x's. A negative 2 minus 5 is a negative 7 on bottom. So it turns out the slope of the red line is 3 over negative 7. So if you compare these two slopes, you've got 2 with negative 3 over 7. They are not the same, so obviously these lines are not parallel. Not only that, they're also not opposite reciprocals. They're not opposite reciprocals. So that means these lines, although they look perpendicular, they are not. And so we have to say that these lines are neither parallel nor perpendicular. Okay? Okay, so to kind of summarize what we talked about in this lesson today, we started out by talking about a perpendicular bisector of a segment. So line segment AB has a perpendicular bisector, the red line, because the red line is perpendicular to segment AB through its midpoint. So that makes the red line a perpendicular bisector, two things there, of segment AB. Then we talked about what does it mean to have the shortest distance from a point to a line. The shortest distance from a point to a line is the length of the perpendicular segment from that point to that line. That's the shortest way to get there from a point to a line is through a line which is perpendicular from that point to that line. Then we talked about slope of a line, which we said was rise over run. Rise is how far you go up from one point to another, and that's calculated by subtracting the y-coordinates of the 2 points on the line. The run is how far you go sideways between 2 points on the line, and we said we calculated that distance by subtracting the x-coordinates. So when you divide those two numbers, the rise and run, you have the slope of the line. And by the way, we also said that if you put that into a formula, which you should memorize, you'll have that slope formula, m, which stands for slope, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then we went through some examples, but the conclusion of all that was this drawing here. If your line rises to the right, it has a positive slope. If your line falls to the right, it has a negative slope. If your line is straight horizontal, it has a slope of 0. If your line is vertical, it has no slope, or we say undefined slope. Finally, we said that if you have two lines that are parallel, they have the same slope. And if you have two lines that are perpendicular, they have opposite reciprocal slopes. All right, that'll wrap it up for these notes. So this video is also posted on Google Classroom also with, I should say, the worksheets for this assignment. So let's go ahead and work on those and enjoy and good luck.